everybody, very good evening and a warm welcome to Vedantu JEE English channel. What's up, how are you all? Yes, quickly go call up your friends as well. This is your Master Teacher Nabamita Mam and today we are here for the second session of S block and we are going to complete it today. Yes, hi Harini, hi Harsha, hello Chaitanya. I'm so sorry Chaitanya. Please do not dislike the schedule. I mean, I was unwell. I had a lot of fever and everything. I mean, you can see that I kind of lost weight also, you know. I really did. Anyway, quickly go call up your friends and come on in everyone. Just waiting for some time. Hi Himashri, welcome everybody. Hello guys. Write down some la. Yes, some la. Good evening, Gaming Vidwan. Good evening, Arjunan. How are you? Welcome, warm welcome, everybody. Yes, I can see that some of you students, how is your health now? Much better. I still do have a little bit of cough and cold, but I think that's manageable. Yeah, that's nothing. I mean, the amount of fever I had and the amount of paracetamols I had, I can't tell you. And to be very honest, I lost around 2-3 kgs. Yeah, I lost 3 kgs just because of this fever. I did not like it. I mean, all my t-shirts and everything is, you know, a little loose. You did not see the few reactions in chemical properties. It's okay, no problem. We're going to talk about it today, yeah? We're going to talk about it today. Yes, we group 2 chemical properties I anyway did not do. I'm going to take it today, okay? Hemant, I'm going to take it today. Yes, Sachit, I am taking care of myself. But you know, Bangalore weather is so weird. Like, there is no concept of winter or summer. Like, even in winter, there will be one day when it is like, you know, peaking hot and then the next day there'll be a little bit of rain and then you're done. It's again winter. So yeah, that keeps happening and it's very weird, which is why a lot of people fall sick here. Hi Harini, very good evening. Yuva, if you want, you can watch you can watch it for NEET as well. I mean, of course, whatever we are teaching, that does not change for JEE and NEET, right? For JEE, it's just a little bit of more advanced, and for NEET, it is specifically your NCERT, you know, questions. Yes. Hi, Space Station. Welcome to the class. Guys, quickly go call up your friends, yeah? Let them know. Let them share it with them as well so that we can start and we can finish it today, okay? Alright, so today we are starting with S block session 2, and in today's session we're going to take a look at the group 2 chemical properties, and then we will talk about some of the important compounds of S block like sodium hydroxide, sodium chloride, sodium carbonate, sodium bicarbonate, calcium oxide, calcium carbonate, and all of that we are going to take a look about it, and then finally the little bit of anomalous behavior, which I'm pretty sure that I have covered quite a bit of it in the yesterday's session. But we will still, you know, just go through that again, okay? Thank you so much, Heyman. Thank you so much. Wonderful Bangalore. You think so. You know, the grass is always greener on the other side. Now that you are here, don't forget to like, share and subscribe to this channel. This is your Vedantu JEE English channel, and you know that this is your only official channel for everything in English. Yes, everything that is related to JEE will be in detailed information in this channel, and all in English, all in complete English, no other languages. Yes, okay. Now moving on, let's start everybody. You all know that my name is Nabamita Mam. However, most of the students, they call me Nobita Mam. So if you want to call me Nobita Mam, sure, go ahead. That's what most of the students do know me. Thank you so much, Deepak. Thank you so much. Okay. So S block, let's begin. Yes, so in yesterday's session, we spoke about this group 1, lithium, sodium, potassium, rubidium, cesium and francium. Because francium is radioactive, we don't talk about it so much. But all the other elements that are there in this group, we do talk about them. And you know why they are also with love, they are called as alkali metals, because whenever they react with water, they form hydroxide, and the hydroxides are strongly alkaline. Come on, take a look at it. NaOH. Don't you know, every time the word alkali comes into picture, we only think about sodium hydroxide because that is one of the strongest alkali, we know it. Or potassium hydroxide as well, that is also one of the strongest alkali, isn't it? So you know that these are alkaline in nature, and that's why they are called as alkali metals. But when we come to group 2 elements, we know that group 2 elements with love are called as alkaline earth metals. Why? Once again, they also form hydroxides which are alkaline in nature, and they are found on the earth crust. Yes, they are found on the earth crust, which is why alkaline earth metals, right? This is what they are called, correct? Just going to revise it a little bit, okay? Now when it comes to atomic size, we know that the first group elements, they have a big size. Apart from noble gases are obviously much bigger, but apart from that, if you look at the whole periodic table, these guys, these fellows, these stupid fellows, they have the highest size, isn't it? They are really big. And the size increases from lithium to cesium because of course we know that as you move down the group, the size increases, isn't it? The size increases. So here also you will get to see the same thing, that from lithium to cesium if you move, then you will see that cesium is of bigger size. Lithium is the smallest of all the group 1 elements. Correct everybody? Do we all remember this? Everything is clear? Yes? We have studied about these things, right? And whatever, I think I made a slight mistake. There was a little mistake in yesterday's session, which I'm going to correct it now. In the slide, it was there. I have already corrected it and it's here, okay? And it's here. Yes, Harini, I'm sure that you probably remember it. In yesterday's session, there was slight confusion with the density, which I corrected in the session. There was also a little bit of confusion regarding melting point and boiling point, that I have today clarified it, okay? Now, when it comes to melting point and boiling point, we know that group 1 elements, they have only 1 electron in their outermost shell and their bonding is actually quite weak, right? And because that is weak, what happens is the melting point and the boiling point are also quite low, okay? Melting point and boiling point are also quite low, and you see that decreasing order of melting point and boiling point. Why? Because this is bigger, right? Cesium is a much big atom, and because it is bigger in nature, what will happen? The forces will be slightly weaker in nature. Yes, the forces acting here will be, of course, weaker in nature, right? Whereas this one is a very small size. Remember that that example I gave you. If you have a big pencil, you can easily break it. But if you have a very small pencil, even to sharpen it, you have to give a lot of force, right? The same way here also, this is what happens, okay? Moving on, ionization energy, we read that ionization energy 1. First ionization energy of this group elements is very, very, very low because they can easily give away 1 electron and they can attain their noble gas configuration, right? They can be very stable, and hence first ionization energy is very, very low. However, second ionization energy is extremely high because once they have given that 1 electron, after that they have attained noble gas, and then they are like, but we are stable, we don't want to give away any more electrons. So they will not give away any more electron, right? So this is what happens. Yes, in group 2 property, group 2, yes, magnesium, we will talk about it. Yes, 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 absolutely. In group 2 only melting point and boiling point. I've got it today, don't worry. Then what happens? Electropositive. What was electropositive? Electropositive was basically giving away 1 electron and becoming 1 positive ion, right? That was electropositivity, and we saw that due to the large size, electron can be easily removed and they can form M+ ion. So electropositivity also increases from lithium to cesium, of course, because size is bigger. If the size is bigger, they can easily give away the electron, right? That is what happens. Density, this was correct everybody. Density is density is directly proportional to mass and inversely proportional to volume, right? And in this case, the mass is predominant. Yes, although volume increases, but not as much as mass increases. And we know that if mass increases, density will also increase. Yes, mass increases, density increases, because both of them are proportional to each other. But what will happen to volume? If volume increases, density decreases. If volume decreases, density will increase because it's inversely related, right? So here we see that density increases because mass increases. Atomic weight increases more than atomic volume. So atomic mass is more predominant. Yes, that is what happens here, correct? Yes, then we read about conductivity. I hope you remember. Flame test, everybody remembers. Acha, by the way, flame test is a little important. If you take a look at the previous year question paper, if you take a look at most of the previous year question paper, then there are questions from flame test. And lot of people think that, color only, no. Why to learn color? It's okay, let it go. Because we think that it's not that important, but trust me, you can get easily 1 mark from this if you just remember the color, everybody. Just have to remember the color. And what was the trick that I told you? Li seems like Li. What starts with Li? Lipstick. Lipstick is, I usually use red color lipstick most of the time. And in fact, I'll tell you what, the lipstick shade that I use, right? It's a Lakme Crimson Silk and it's red. This is the one that I'm wearing right now. I mostly use red color lipstick. So I know that LI is what? Lipstick, and lipstick is crimson red. This is what I told you yesterday. Yes. So from there you can also remember it. In fact, like I said, my Lakme, the shade that I use, that is only crimson silk. So I remember it very clearly. Crimson silk, crimson red. So Li will give you crimson red. Sodium will give you golden yellow. S for sodium, yes. K is violet. Rubidium, ruby. The word ruby is only used for red, isn't it? Ruby red we say. So there, rubidium, the word has ruby. From there you can remember red, violet, and cesium has C. C is blue. So blue, okay? Alright, that's how we remember it. So please do take a note of this, okay? Do make a note of this, because there might be one question and you can easily, without even lifting your pen, without even thinking so much about it, you can easily answer this. So don't forget it. Please do note it down. It's very easy. You don't have to study so much. Just have to remember this, and it's easy, right? Moving on. Photoelectric effect again. I told you here, what is the godfather? The godfather is the fact that ionization energy, and they can easily give away their electron. So photoelectric effect, why do we see photoelectric effect? Because the electrons that are in the outermost shell, they can easily be excited and they can come back. So when they can come back, or when they get excited, what happens? They give away. You will be able to see photoelectric effect. You will be able to see photoelectric effect due to very low ionization energy, right? So photoelectric effect is also seen especially in potassium, rubidium and cesium, okay? We have covered this. Standard oxidation potential covered. Chemical properties of group 1 was also covered, if you remember, everyone, right? Hi Abhishek Ingle, hi everybody. Reaction with air, do you remember reaction with air? Yes. Reaction with dry air was taught. Reaction with moist air was also taught. And if you remember, what was it? Oxide, peroxide, superoxide. Lithium will give you oxide, sodium will give you peroxide, and then potassium, rubidium, cesium will give you superoxide. OPS. Yes, that's the trick to remember. OPS. Oxide, peroxide, superoxide. Oxide, peroxide, superoxide. Yes. Do you remember this? Do you remember this part? We have covered this also. Okay? We have covered this also. Reaction with hydrogen also we know. Then there was, yes, see, lithium requires more than 1000 Kelvin, whereas rest all of them require only 673 Kelvin, and they react with dihydrogen to give you ionic metal hydride. Yes, hi Tilagavati, welcome. Long time I haven't seen you in yesterday's session. Yes. You're watching chemical properties. Yes. Yesterday we have covered all of these, okay? Reaction with water. Do you remember? What happened here? Yes, alkali metals, they react vigorously with water. We know that, right? Don't we? Even in our lower grades we have studied, no, sodium, you put it in water, boom. Sodium reacts vigorously with water, and what does it form? It forms metal hydroxide and hydrogen, obviously, and the metal hydroxide will be alkaline in nature. There is nothing more. There is nothing new that we are learning. We have already learnt all of these in the lower grades. Is Vedantu enough for JEE? Absolutely, my dear student. Have you seen how many students we have? For JEE? Have you seen? Last year also there was more than 1500 students who got selected. Last year also more than 1500 students were selected for JEE. So yes, Vedantu is enough, but we promise that we will give our best, but you will also have to meet us halfway there. If we are doing rest of the half work, you will also have to study properly, be with us, and don't hover around everywhere. I just recently made it. It's not too late to prepare for JEE, but make sure that there are few things that you do, okay? Don't go to each and every class. You will just be wasting your time. Follow one teacher per subject. You will be beneficial because you know that teacher is going to take care of you. You go to every single class, you'll just be wasting your time. Don't follow so many reference books. This is also something that I told you. So remember all of that, and if you prepare like that, you will definitely get there, okay? You will definitely get there. And then rest, I know that you all are very intelligent and you are sharp students, you can get it. Chalo, moving on. We know that lithium is the least reactive towards water. Sodium reacts vigorously. Potassium reacts producing a flame. Rubidium and cesium also reacts explosively. Achha, you know what? Shall I tell you a story for this reaction with water? I think you will all be able to remember it because this is how I remember it. And I don't know if I have told you. So when I was in my 12th standard, right? When I was in my 12th standard, and like I told you, even in yesterday's session, I was in Kendriya Vidyalaya, right? I was in Kendriya Vidyalaya. Now Kendriya Vidyalaya is a government school, right? It's a government school. Everybody is allowed to do whatever they want to, yes. And we have facilities. It's not like we don't have facilities. We have everything, and we have top of the notch everything. But then the students are such ishtubits, okay? The students are such ishtubits that we don't care about what we have. Everything that comes is top notch, and we break it down in like 2 to 3 days. This is what we do, okay? It's not a good thing, but I think these are the memories that you remember it. So there was this one guy in our class whose name was Praveen. I even remember his name. His name was Praveen. Now our teacher, and our teacher's name was Sir Rakesh Joshi sir. He's still there on my Facebook. I still talk to him. So Rakesh Joshi sir was our chemistry teacher. He took us to the lab, and he was showing us how sodium reacts with water. He was doing this experiment, like physically right there. He was doing it, and he was showing it to us, right? So what happened was, he took forceps, he took a little bit of sodium, and he just put that in the wash basin, and what happened? Doom, bum, 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 and there was fire and everything. We saw it, we were like, yay, nice, we got it, we understood the reaction and everything, that this is how sodium reacts with water. Now this Praveen fellow, he got an idea. He was like, I'm gonna take a little bit of sodium and I will show it to my friends, okay? Now he was, of course, a little bit stupid. He did not know how to take it home, right? So what he did was, he took a little bit of sodium and he nicely wrapped it in aluminium foil and a little bit of tissue paper and everything, and he put it in his pocket and he was going. Now Praveen used to stay quite close to school. Yeah, I used to stay 12 kilometers away from school, so I had to take the school bus. But Praveen used to stay quite close to school, and imagine what would have happened. Sodium was in his pocket, he was going to his home, and it started raining. I could see it from my bus that fellow got fire on his pocket, and his pant was burning. While the school chutti happened, his pocket was burning right in front of the gate. And you know, more than Joshi sir showing us the experiment, what I till date remember is how sodium reacts with water only because his pocket was burning. This is how I remember. I'm not kidding. This really happened. This has happened to us. So till date, I remember that sodium reacts quite vigorously with, water. I remember this, that it reacts vigorously, and from there I learned the word vigorously because I know that fellow's pant only burnt, yeah. After that, he never took away sodium from the, lab. This is what happened. So will you all be able to remember it? This is the funniest story that I have seen in my life, So yeah, that happened, and you know that sodium reacts vigorously, potassium reacts producing a flame, and rubidium and cesium, they also react explosively. Isn't it funny? So that happened. After that, we also spoke about reaction with halogen. What are halogen? Fluorine, chlorine, bromine, iodine, all of that. Yes, how do they react? Yes, how do they react, everybody? Do you remember the ionic nature of Mx, metal halide, increases from lithium chloride to cesium chloride. If you remember, lithium will form covalent bond because it's chuttu size, whereas cesium has a bigger size, it forms a ionic bond, okay? Alright everybody, moving on, reaction with nitrogen is done, formation of amalgam is done, solubility in liquid. From here JEE questions has come and might come again, everyone. Hi Atibhan and hi Raghavan, welcome everybody. From here JEE questions have come, so please make a note of it, everybody. Please make a note of it. And the question was, see, the blue color, the blue color and reducing nature of solution is due to presence of ammoniated electron. This is your ammoniated electron. Please make a note of it, okay? Please make a note of it. Because of this electron, that is ammoniated electron, what do you get? You get the blue color and reducing nature. This has come in the exam. Make a note of it, might come again. From this solubility in liquid ammonia, there have been a lot of previous year questions. You might be able to see them, okay? Alright, moving on. Group 2 physical properties were done yesterday only, but let's just take a look at the chemical properties. Yes, this is where I made a mistake yesterday. This was not properly written. So yeah, metallic bond is stronger than the first group, obviously, because here there are 2 electrons in the outermost shell, right? There are 2 electrons in the outermost shell, so obviously the metallic bond is going to be slightly stronger than group 1. Group 1 only had 1 electron, right? Yes, and plus they are smaller, because we know that along the group, what happens? The size decreases, right? So group 1 has the highest and the biggest size, whereas group 2 has slightly smaller size. So due to smaller atomic size and 2 electrons in the valence shell, what will happen? The metallic bonding is stronger, and because metallic bonding is stronger, obviously melting point and boiling point will be both higher. Now, take a look at it. The decreasing order of melting point. Yes, what is happening? Beryllium has the highest, then calcium, then strontium, then barium, and then magnesium. Magnesium has the least. Okay, magnesium has the least. Now, coming to boiling point, again we see that beryllium, barium, calcium, strontium, magnesium. Again, magnesium has the least. Magnesium has least melting point and least boiling point as well. If you want, here is the chart. Everybody, take a look at it. Take a look at it, my dear student. See, this is the melting point of magnesium, 924 only. Even radium has higher than that. Yes, 924 only. Okay. Here also, if you see, 1363 only. See, it decreases from top to bottom in the group, but magnesium has exceptionally low and barium has exceptionally high boiling point. Okay, and barium has exceptionally high boiling point. Do we see it, everybody? Understanding, guys? Understanding? This was the only mistake because of the slide. The slide was not, the slide was, when you change it from Google slide to a PowerPoint, there was some disorientation in the slide, which is why we could not cover it properly yesterday. Now, is this all clear, everybody? Is this all clear? Melting point, boiling point, clear hai? Clear hai? Can I get some la 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 in the chat box, everyone? Some la 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 in the chat box, everybody. Go ahead, quickly. Okay, all right. Density was also done here. Oxidation state was also done. Electropositive metallic character. See, density once again, everybody. Density. In general, we say that density increases from beryllium to barium. But however, in ideal scenario, this is what should happen. But we know that calcium has the least. Yes, calcium has the least density, then comes magnesium, then comes beryllium, then comes strontium, and then it is your barium. Yes, this is what it is. Moving on. Conductivity is also something that we have learned. Now here, in case of flame test, do you remember that story that I told you about my brother, and I told you that beryllium and magnesium, the top element always acts a little crazy, right? The top element always acts a little crazy, and hence you will see that beryllium and magnesium, they are not going to show you any flame test. They will not be giving you any color. Why? Because beryllium and magnesium has really small size. Because of the small size, the electrons are bounded slightly tightly. Okay, the electrons are bounded tightly. They're not very loose like the other like the other elements of the group, and that is why they do not show you the flame color. However, you will be able to see it in calcium, strontium and barium. Now, how do we know what is calcium, strontium and barium? If you remember, calcium is brick red, strontium is crimson red, and then you get apple green. Take a look at it. See, brick red, crimson red, apple green. Three only 3 you have to remember, right? Only 3 you have to remember. Easy, correct? Calcium, brick red, strontium, crimson red, and barium is apple green. Cool, everybody? Photoelectric effect done, standard oxidation potential done. Chemical properties. Let's come to chemical properties. Reactivity. What happens to the reactivity? What do you think? They are slightly less reactive than the alkali metals, obviously, because this time the sizes are also smaller, right? They're not going to be as reactive as the group 1. Group 1 had only 1 electron to give it, and it was very happily, very excited to give it away. But here they have 2 electrons. They give 1. The ionization energy of the first one is also slightly lesser than group 1. But it is slightly more than group 1. But ionization energy 2 is very little. Why? Because after giving 1 electron, now they are excited to give away the other electron just so that they can attain the noble gas. Correct? Yes, and plus because we know that barium has the highest size, so you will see that the order of reactivity increases as we move down the group. Correct, everybody? You see that beryllium is of the least. Yes, then magnesium, calcium, strontium, barium. Barium has the highest reactivity because size is bigger. It can easily give away its electron. Correct? Moving on, reaction with air. This time. Once again, coming back to the same topic, take a look at beryllium. Yes, take a look at beryllium. What will beryllium do? Beryllium will be like, you know what? I am not going to react. Beryllium says that I am not going to react. Yes, why does beryllium say that? Why does beryllium say that? The top one, no? The top element, it's the smallest in the size. It is going to act a little crazy. It does not want to react. However, you know what you will have to do? On normal conditions, under normal conditions, it is not going to react. But if you powder it, then it will be like, It's like, you understand, like you know what? Without any reinforcement, if I ask you, bacha log, you know, you have to study every day 2 hours and you will get through JEE. No. After 1 month, some students will again come back. Ma'am, is it too late to start for JEE, ma'am? Is it too late to start for JEE, ma'am? Even in March, when April, where they will have exam, they'll be like, ma'am, is it too late to start JEE, ma'am? They will do that, right? Yes. But one day if you scold them, like Shreyas sir, that day he said, no, angry Shreyas sir is angry. Enough is enough. After the student will study. What happened? They got scolded. They were powdered. Yes. There was a slight bit of external force that was asking them to study. So here also, once you have powdered it, once you have provided some bit of external force and you have powdered it, then beryllium is like, I got beaten up. I'm going to react now. Then beryllium is going to react. Otherwise, under normal condition, it is not going to react. Whereas all the other metals, okay, whereas all the other elements present in the group, they get easily tarnished in air, okay. In moist air, what is happening? This was only about dry air. Now, in moist air, except beryllium, all the elements, they will convert to carbonate. Why? Because in air, there is carbon dioxide also, no? So, yes, they will react and they will form carbonates, okay, they will form carbonate. In dry air, all elements of group 2 will give nitride and oxide both. Yes, now let's talk about their oxide. What kind of oxide do they form? MO, like BeO, yes, CaO, magnesium MgO, yes, that's the kind of oxide they will form, okay, all right. Only, yes, but, remember in the last one, what was it? Oxide, peroxide, superoxide, oxide, peroxide, superoxide. Do we have something like this here also? Yes, we do. But we see that only calcium, strontium and barium, they form peroxide. What do they form? Peroxide, no superoxides. Here there is no scenario of superoxide, only peroxide. Beryllium, magnesium gives you oxides, whereas calcium, strontium, barium will give you peroxide. Got it? Alright, understanding everybody? Now, you see that the calcium oxide, strontium oxide and barium oxide, they are strong basic. Yes, they are very strongly basic in nature. And of course, we know that, right? Even in our lower grades, we have studied that metallic oxides are basic in nature. So, you see that these are basic in nature. Magnesium oxide is also basic in nature, weakly basic, but still basic, right? Basic nature it is showing. Correct everybody? Basic nature it is definitely showing, weakly basic, chahe weakly basic, but still it is basic. However, beryllium oxide, once again acting as little crazy, this is amphoteric in nature. Please do make a note of it. Yes, this is amphoteric in nature. So, what can we talk about the basic properties? Can we say that basic property increases from beryllium oxide to barium oxide? Yes, we can. We know that barium oxide is strongly basic. However, beryllium oxide is amphoteric in nature. So, we say that in the group, yes, while going down the group, you see that the basic property, it increases. Clear? Everybody clear? All clear? Any doubt till here? Any doubt till here? Shall we move on? Let's move on to reaction with hydrogen. Everybody, Gaming with Van, Mr. Introvert, Raghavan, Harini, Jabin. Yes, are we done? Are we done? This is clear? Is this clear or not, guys? No answer. No one is interacting. Are you guys alive? Check, check. Hi, Pooja. Okay, Pooja is saying yes. Jabin is also saying yes. Okay. Clear, clear, clear. Clinical clear, no? No dandruff. Clinical clear, huh? Clinical clear. Okay, great. Now, Let's go to reaction with hydrogen. Except beryllium, you will see that all the other alkaline metals, what do they form? They form hydride. They form hydride. But the type is MH2. Obviously. Of course, 2 hydrogen will be required. No? 2 hydrogen will be required. Correct? Because they have 2 electrons to share. So, 2 hydrogen will be required. So, MH2. But beryllium, once again acting a little crazy, beryllium is like, I'm not forming any hydride. Yes, beryllium will not form any hydride, whereas magnesium, calcium, strontium, barium will. They will form hydrides. Okay. Now, but again, once again, see. Oh, thank you so much, Zahid. Thank you so much. Hi, Hemant. Welcome. Please share it with your friends also. I see that at 5 o'clock, very little students come. Yeah, I think I should change the time. Do I have to change the time? I might have to change the time because many of you come from school and I don't want you all to miss out on the live lectures. Or maybe on Saturdays we will do the strategy based videos so that you can watch it later also and you can understand, right? The rest on the other days we will do the academic topics. That makes more sense, I guess. That makes more sense. We'll do that. Anyway, talking about it. Now you would think that beryllium probably does not react at all. Or beryllium probably does not give you any hydride at all. But that's wrong. That's wrong. You can actually get some beryllium, but you will have to take another route, you know. Beryllium is, it's just not normal. It's just not normal. Like I said, remember yesterday, like like my brother who is the younger one, right? If somebody wants to talk some sense to him, it's not going to be the usual route you can take. You just can't tell my brother that, you know what, my mom and dad just can't go and tell him that you can't do this, you must do this. He will not listen. They tell me that I'll be like, whoa, mom is scolding, I must listen, right? That works with me, but it doesn't work with him. For him, my mom and dad will be like, bacha, shona bacha, you might do this. If you don't do this, we will not give you money. Only then he listens. Only then he listens. So that's a different route. Like for me, my parents only had to say that you don't do this, we are going to be very angry with you or we are going to be disappointed. I'm like, you know what, don't be disappointed, I'm going to do it. I'm going to be that good child you want. But then my brother, you tell him, he's like, what are you going to give me? First bring me my money. First bring me my money. Only then I'm going to study. See, different route. So here also for beryllium, you will have to take a different route. You will have to take a different route. You will get good yield of beryllium hydride also. You will get BeH2. But for that, you will need LiAlH4. So if you take beryllium chloride and if you make it react with LiAlH4, then what will happen? You will get beryllium hydride and you will get lithium chloride and aluminium chloride out. So from here you get a good yield. From this reaction you are going to get a good yield. Good yield means you are going to get a nice produce of beryllium hydride. Otherwise, if you normally try to make it react, it will be like, yeah, not doing it. Not doing it. This is what will happen, okay? And once again, everybody take a look at it. Beryllium hydride and magnesium hydride are covalent, whereas all the rest of them are ionic. Why they are covalent? Small size, small size. Small size will form covalent bond. Rest all of them will form ionic form. Yes, we have to beat up. Yes, so how are we beating it up? We are trying to beat it up with lithium, aluminium, yes, LiAlH4. Cool? Now, reaction with water. What will happen if we make it react with water? This is the fourth chemical property, my dear student. These metals, what do? They react slowly. Unlike the group 1 was crazy. They're like, oh my God, water, let's bring some fire in our friendship, right? This is what happens with the first group. But group 2, they're like, okay, water, okay, good, big deal. Yeah, so why are you in city? They're going to be like this, right? They are friends, but not so much, like, you know, not so much. So anyway, now these metals react slowly with water and they give you hydrogen and the metal hydroxide. Obviously, metal hydroxide is necessary. That is why they are alkaline in nature. No, metal hydroxide is necessary. But beryllium does not react with water. This time beryllium does not. Magnesium reacts. Magnesium does react with water, but only with hot water. Magnesium is also a little snobbish, you know, little snobbish, like water. Why should I react with you? Give me 10 reasons why should I react with you. This is what magnesium will be like. And then water will be like, you thought I'm weak. I'm going to tell you why you should react with me. Let's bring my temperature a little higher. Now, do you want to react? It will react. It will react with hot water. See, it will react with hot water, but not with cold water. Anyway, calcium, strontium, barium, they react with cold water, but not as energetically as group 1. Again, yes, of course, they are not as reactive as them also, right? And once again, the basic nature increases from beryllium hydroxide to barium hydroxide. Or see, simple, very similar to the group 1 also, but just slightly different, okay, slightly different. Now, reaction with halogen, once again, what are halogen? Chlorine, bromine, iodine, astatine, those are all halogen. So, what do we see? The metal reacts with halogen, but this time you will have to heat. Yeah, this is heat. Heat is a requirement in this reaction. Heat is a requirement, and then you get the MX2. Then you get the metal halide. What is the order of ionic nature? Once again, see, ionic is less. In case of beryllium and magnesium, the ionic nature is less. But as you go down the group, you see that barium chloride is quite ionic in nature. Yes. Hydrolysis tendency of these halides, that also decreases from beryllium to barium chloride. Why? Because decrease in covalent nature. Decrease in covalent nature. Yes, because of decrease in covalent nature, the hydrolysis tendency also decreases. Okay. Alright. Now, beryllium and magnesium chloride, they are covalent in nature, which I already told you. You know this already. So, nothing to go for it again. Yes. Now, reaction with nitrogen. Okay. So, all the elements of this group, yes, beryllium, magnesium, calcium, strontium, barium, all of them, what do? They burn in nitrogen to give you M3N2. M3N2. Remember, oxide was BeO, MgO, right? It was MO. How they were forming oxide was MO. However, calcium, strontium, barium were also forming peroxide, right? But here, take a look at it. What is it? What are they giving you? M3N2. M3N2. Remember, M3N2. This is what you get, okay? Now, the alkaline earth metals, they also react with mercury and they will give you amalgam. And these metals, they will react with other metals to give you mixed metals as well. Alloys also is their one of their strength. Okay, solubility in liquid ammonia, and I think that's it. We are done. Okay, now only calcium, strontium, and barium will give you blue solution. Yes, ammoniated electron. Because of the ammoniated electron, you will get the blue solution. Same thing. Remember, I told you that this question has come in the IIT JEE advanced mains as well. Take a look at the previous year questions, or when I do the important questions, I will discuss this again. This point is important from this chapter. Do make sure that you read it. Okay, ammoniated electron is the reason for blue color and reducing nature. But beryllium and magnesium are small in size and they have high ionization energy. So they will not dissolve in energy. They will not dissolve. Okay. The dark blue color of the solution, if you keep it standing for some time, right? If you keep the jar as it is, if you keep the flask as it is, or the container as it is for standing for a long time, just keep it as it is for a very, very, very long time, what will happen? The blue color solution will fade away. Why? Because you will see formation of metal amide. What happens? Formation of metal amide is seen here. Okay. Formation of metal amide is seen here. Because of that, the blue color solution fades away. But this only happens when you keep it standing for a long time. Understanding? Only if you keep it standing for a longer time, only then you will see that the blue color fades away. Otherwise, you will not see. Otherwise, initially what will happen? You will get the blue color because of ammoniated electron. Are you understanding, everybody? Is this clear, guys? Is this clear? Lithium, however, forms imide, my dear student. Okay, lithium forms imide. Li2NH it forms. What does it form? Li2NH. Whereas all the other ones, you will see that they form this kind. Okay, they will form. Where does it go? Where is it? Where is it? Yeah, they will form M3N2. They will form M3N2. Only lithium will form a imide as well, Li2NH. Okay, Li2NH. All the other metals, what do they form? They form, see, on increasing the concentration of metal in solution, it will convert into bronze color due to cluster formation of metal ions. If you increase the if you increase the concentration of metal, then they will form a bronze color due to cluster formation of metal ions. Understood? Priyansh is the only one who is like, oh, Thanks. I like your excitement for this. Thank you so much. Yes. So is this understood, everybody? Now we're going to compounds of S block, and that's it. We will be done with the chapter, everyone. Is this all clear? Any doubt till here? Any doubt till here, my dear student? Yes. Shall we start with the compounds? All la la la? Okay. All right. Everybody is saying la la la. I'm happy then. I'm happy. PCB is done by me, but maths doesn't work. How? Dr. Sanjay Kumar, have you tried following Shimon sir? Please follow Shimon sir. No, please follow. Santosh Kumar, yes, I'm taking you through most of the majority of the important questions as well. S block is not done here. I'm also going to take a session on important questions for S block, wherein we are going to discuss previous year questions that have come in JEE Mains, JEE Advanced. And yes, I'm going to take you through. This lecture will be enough. This lecture will be enough, but I would want you to make notes as well on your own, because the notes that you make on your own are the most important thing for your exam. So please do make sure that you make your notes, and make sure that you are also reading my notes, and watch the lectures. Before exam, when you're watching the lecture, watch it in 2x speed. Okay, watch it in 2x speed, so that everything is just revising in your head. You don't have to watch it in, breaks and pieces, bits and pieces, slowly, steadily. No. With sir, Shimon sir. Yes, you will win. What's your doubt? Please do let me know. Solubility in liquid ammonia. Teach again. Solubility in liquid ammonia. So you take some liquid ammonia, put the metal in. What happens? The metal reacts with liquid ammonia, and it actually, what happens, reaction also bhul jao, okay, forget about the reaction also. What happens is they are soluble. The metals are soluble in liquid ammonia. Why? Because they give you a cation, MNH3 plus ion, okay, they will give you a cation, and there will be an ammoniated electron. The metal will release one electron, but the electron will also be engulfed by ammonia, and that will also dissolve. And that ammoniated electron is the reason for blue color and the reducing nature of it, okay. That is the whole reaction of liquid ammonia. However, beryllium and magnesium, they don't really react, because they have a very small size of their atom, and they don't react. Rest, all the other elements, they react with ammonia. Understood? Yes? Understood? You will win? Clear hai? Now, in case of compounds of S block, everybody, write it down. There are 4 compounds that you are going to learn about, okay? There are 4 compounds that you are going to learn about. What are the 4 compounds that you will learn about? For group 1. For group 1, you will learn about, alright? What happened to this? Chalo, let me write it with this only. For group 1, you will learn sodium chloride, तेज का नमक, टाटा नमक, शुद्ध नमक, sodium hydroxide, which is your caustic soda, yes, sodium carbonate, and of course not to forget our pretty cake making sodium bicarbonate. These 4 compounds we are going to read, okay. Ma'am, please tell briefly about chloroform, iodoform and carbon. Sanjay Kumar, not today. Today we are doing S block, no. If I start teaching you this, all the other students who are coming here to watch this session later, they will all get confused. How about I tell you this when I teach you, okay? I'll tell you this, don't worry. Promise, I'll teach you this, but not in today's session. Huh? Chalo, moving on. Now, let's start with sodium chloride. Achha, sodium chloride. Please just read this line and tell me that you haven't understood this. Just read this line. Don't we know about physical change, crystallization? Remember crystallization process? Yes, what is crystallization? Take the sea water in a shallow, place, and then let the water evaporate. That's your crystallization. So, sea water is the main source, and it is found in salt lakes also. So, that is where your sodium chloride is occurring naturally. It occurs naturally. But, so you took the sea water, make a shallow pond kind of thing, okay? Let the water evaporate. Evaporation by solar heat, what do you get? Crude oil, crude sodium chloride. Now you're going to ask me, ma'am, what is this crude NaCl? Crude NaCl is raw NaCl. Hindi mein kacha NaCl, which has a lot of other things in it. So crude NaCl is not pure NaCl, my dear student. Crude NaCl is not pure NaCl. For example, we say no crude oil. What is crude oil? Petroleum is that crude oil. Petroleum, you know, you dig it out from the underground, and that smells like drainage. It's that raw petroleum, dark black color, and smells horrible. But after that, when it is purified, when it is, you know, distilled properly, then you get petrol and diesel, and kerosene has a beautiful blue color, smells nice, right? I mean, if you make me stand in front of a petroleum, I'll be like, ah ha ha, such nice smell. I like it, I'll stand there. But petroleum, you can't stand there. So crude is raw, the first thing that you get. So here also, just after evaporation of the water, the crystallization of salt, what do you get? You get crude NaCl. This crude NaCl has a lot of impurities in it. That means you can't eat it. So the normal salt, the table salt that is there on the dining table, which you put Tata Namak, Desh Ka Namak, Shuddh Namak that you put, it's not this. This is crude. You can't eat it. You can't eat it. Whatever salt you get in your home, that has been refined through lot of processes, and then it reaches your home. Then you eat it and you'll be like, oh, ha, ha, the chicken curry is so nice, right? But if you put this, you'll be like, ugh, because there will be some metallic taste and all of this, presence of metals, presence of impurities. You can't eat it. Anyway, so the impurities that are present in it are Na2SO4, MgCl2, CaCl2, CaSO4. These are all the impurities that are present. So once again, everybody, crude sodium chloride. Crude is the raw sodium chloride, which has a lot of impurities in it. What are the impurities? Na2SO4, MgCl2, CaCl2, okay, CaSO4. These are the impurities that are present in. Now what you have to do is, you will have to remove the impurities. For you to be able to get sodium chloride, you need to remove it. How will you remove it? Insoluble impurities. How can you remove it? Filtration. Easy. Why make our life harder? We will do easy, right? We will filter it. Once we filter it, then what do we get? Once we have filtrated it, then you get some residue and you get some filtrate, right? Once you have filtered it, you get some residue on the top of top of the funnel, and at the bottom you will get filtrate. So take the filtrate, okay, take the filtrate, and then what will happen? HCl gas, hydrochloric gas will be passed. Once you pass hydrochloric gas, you will get pure sodium chloride precipitation. What will you get? Pure sodium chloride precipitation. And MgCl2 and CaCl2, they are more soluble in water, so they are left in the solution. They are left in the solution. Acha, here is a word that you probably do not know. Let me tell you. These two, no, they are called as deliquescent in nature. Deliquescent in nature. These two salts, they are deliquescent in nature. What do we mean by this? What do we mean by this deliquescent? That means that they have a tendency to, you know, be in the liquid form only. They have a tendency to be in the liquid form. They absorb water very well, okay. So this is their tendency, deliquescent in nature, okay. Deliquescent in nature. Understood, everybody? They are deliquescent in nature. What happens if we drink alkali base during... Okay, Sanjay Kumar, it depends on what kind of alkali, okay. If it is a very diluted NaCl, then you are allowed to pipe it. Then you are allowed to pipette it out, okay. If it is concentrated, then of course no, you will not be allowed to. Alright, so it depends on what kind of alkali. Sodium hydroxide is also present in our soap, but it's a very diluted amount, a little bit of amount, and that's why you put it on your skin, nothing happens, right? But if it was concentrated, it would have burnt it. It is corrosive in nature, right? It depends on what kind of alkali you are talking about. Oxalic acid, you also drink acid, right? You also pipette out acid, but oxalic acid is a very you know, it's a very weak acid. So if you pipette out oxalic acid, only thing is, too much of oxalic acid in your mouth, it will just be a little bit, you know, how do I say, it'll be just slightly weird tasting in your mouth, but you won't die, nothing will happen. Namaste, Optimal Learning with VR. Thank you so much for coming to every class, yeah. That's so sweet of you. Chalo, properties. Acha, sodium chloride properties, should we tell you? Yes, I'm going to tell you. And Harini, very good. You have written it first only, hygroscopic in nature. What is this hygroscopic? Have you left sodium chloride on just a table? Yes. In a bowl, keep sodium chloride, just a little bit of sodium chloride in a bowl, in open. What will happen? very nicely within a day it will become liquid. It has the capacity to absorb water from the atmosphere, and it will try to become liquid, or it will try to form lumps. You must have seen, right? So that hygroscopic nature is present with table salt, okay? And also it's because of the presence of magnesium and calcium chlorides in slight amounts. And what is their nature is deliquescent. I told you, deliquescent, hygroscopic. Yes, magnesium and calcium chloride are present in small amounts, and that's why it makes it hygroscopic. Acha, now table salt, sodium chloride, that is, it can also react with silver nitrate. Yes, it can react with silver nitrate, and it will become sodium nitrate and silver chloride. You will get white PPT. Doctor, how it will be liquid? Dr. Sanjay Kumar, it's its tendency. Yes, it's the property of sodium chloride because of the presence of magnesium and calcium chloride. Yes, what will happen? They will try to turn into liquid, okay? They will try to turn into liquid. It's a nature. It's a nature. Are you getting it? Yes, what is the primary composition of NaCl? After all the Ramayana is done, then you are asking, ma'am, Sita was a boy or a girl, ma'am? If you ask me these kind of questions, optimal learning with VR, then I'll have to sing Mar Dala. Why this question, bro? Why? Primary composition of sodium chloride is sodium and chloride only. No, you can read it. NaCl. What else? What are you asking me? Chalo, anyway, moving on. Now let's go to sodium hydroxide. But wait, I have to drink a little bit of water. Yes, I have to drink a little bit of water. Acha. How do we prepare caustic soda? Caustic soda is the, lovable name of sodium hydroxide. How many times will we say sodium hydroxide, sodium hydroxide? Like, you have given me the name. Like, my name is Nabamita Bhattacharya. It's such a huge name. By the time you go Nabo, I'm like, kya? 3 times I can go kya, right? Such a big name. So instead of calling me Nabamita Bhattacharya ma'am, what will you call me? You call me Nobita ma'am, right? It's a short and simple name. Yes, the PDF will be available today, bacha. I wanted to give it to you yesterday only, but yesterday I had to run because I had to go somewhere else. But today I'll give it to you. I have a little bit of time. After this class, I'll give it to you, okay? The PDF, in fact, most of the PDFs are ready. I have made a folder. I will share it with you in the Telegram channel, okay? I'll share it with you in the Telegram channel. And then from the Telegram channel, we will download it and we will put it in the sessions also, okay? Now, how do we prepare? How do we manufacture sodium hydroxide, which is also called as soda? Not like normal soda, it is caustic soda, okay? Caustic soda, sodium hydroxide. How will you manufacture? By electrolysis of sodium chloride. How do we do it? Here, you will need a Nelson cell, okay? You will need a Nelson cell or diaphragm cell. What will happen? The cathode will have perforated steel, where you will get hydrogen gas, and at anode, you will get chlorine, okay? At anode, you will get chlorine. See, this is also a redox reaction, right? This is also a redox reaction, isn't it? Yes, apart from Nelson cell, this is important. Kastner-Kellner is very important because on Kastner-Kellner, you will see, okay? You will see previous year questions also. Kastner-Kellner is slightly important. Please make a note of it, everybody. What a pure NaCl precipitate as a result of the optimal learning I have just taught you, bacha. See? Pure NaCl precipitation is the result of when you take the filtrate from this reaction, right? Crude NaCl, you filter it, remove the insoluble impurities. Hi! Come on in, let me introduce you. Come. Now the students will be like, who had come? Anyway, yes, yesterday I ate cake. I'll give it to you later on. Acha, chalo. Moving on, focus up, everybody. Yes, optimal learning with VR, you were asking me, right? See, what do you take is, you take the crude NaCl, you filter it. After filtering, take the filtrate, pass HCl gas, you will get pure NaCl precipitate, which also has a little bit of magnesium chloride and calcium chloride, which makes the stable salt hygroscopic in nature. Understood? Optimal learning, I think you were a little late, bacha. Please rewind and watch it again. Huh? Chal, moving on. Kastner-Kellner cell. Kastner-Kellner cell is slightly important. Please make a note of it. Like I said, in the previous year questions also, you will see there are some questions that are based on this. What are we going to take? We are going to take electrolyte. What electrolyte? Brine solution. What is brine solution? Does anybody know what is brine solution? Brine solution is basically saline water, but salt is concentrated. Sodium chloride is concentrated in brine. You take that again at cathode. Cathode is mercury. Cathode is mercury. So at mercury you are getting amalgamated sodium. You are getting amalgamated sodium. At an anode, anode is graphite. At anode you are getting chlorine. Okay. At anode you are getting chlorine. Now this amalgamated sodium, just add some water, you will get sodium hydroxide. That is the preparation. That is the preparation. Yes, Sanjay Kumar, you are right. Understanding everybody? Kastner-Kellner cell, not too hard. The name sounds like, whoa, what is this? But it's not like that, okay? Kastner-Kellner, you will have mercury as cathode. Mercury as cathode. So what do you get? You get amalgamated sodium. In that NaHg, you just have to add water and you will get sodium hydroxide, hydrogen gas and mercury. That's it. That's it. Hi Shivagami, my name is Nabamita Bacha. My name is Nabamita Bhattacharya and I'm your chemistry master teacher. Okay. Now, again, once again, sodium hydroxide, see, deliquescent. We have the same word, repeated. So today we also learned a new English word, isn't it? We also learned a new English word. What is it? Deliquescent white crystalline solid. Okay. It does absorb carbon dioxide from air and it forms sodium carbonate. Normally the sodium carbonate is forming here also. Then why are we learning the preparation of sodium carbonate? Yield, my dear, yield. This will be very little, but we need more of sodium carbonate, right? And that is why we will have to study the preparation of sodium carbonate as well. Alright, now sodium carbonate, sodium hydroxide. What is the nature of sodium hydroxide? Strong base. So do you think that it can react with silicon oxide? Silicon is a non-metal. Non-metallic oxides are acidic in nature. So what will you get? See, reaction will happen. Reaction will happen here. Do we observe it? Easy? Easy. Preparation of sodium hydroxide. Yeah, we are moving there. Only sodium hydroxide. After that, we will talk about sodium carbonate and sodium hydrogen carbonate also. Do not worry. Yeah, do we understand this, everybody? Easy? See, sodium hydroxide is a strong base. It will react with non-metallic oxides which are acidic in nature and the reaction will occur. Cool? Moving on, reaction with non-metals. See, it will also react with hydrogen and nitrogen and carbon and sodium hydroxide can react with, see, what will it form? Sodium borate. It will react with boron, form sodium borate. It will react with silicon and it will form sodium silicate as well. Cool. It can also react with metals. Yes, it can also react with metals, but can it react with alkali metal? No, not possible. It cannot react with alkali metal, no reaction here. But with aluminium, beryllium, zinc, tin, plumbum, it can react. Okay. Alright, it can react. And on all of this, do you see the common factor? Hydrogen gas. Hydrogen gas, my dear student. Hydrogen gas is the common. Okay. How reaction occurred? Hey, alkali will react with acid, no? Alkali will react with acid, no? Yes. Optimal learning with VR, are we doing coordination compound? Huh? Are we doing coordination compound today? No. Then why are you asking me all of that now? Today we are doing S block, no? Focus here. Chalo. Now sodium hydroxide. The hydroxides of aluminium, zinc, lead and tin, however, they dissolve in excess of sodium hydroxide and they will give you clear solution. They will give you clear solution. But this can also be, so you not only need excess of sodium hydroxide, even if you take concentrated solution of sodium hydroxide, you will still get a clear solution. That is also possible. Alright, yes, moving on. Reaction with zinc chloride. How does sodium hydroxide react with zinc chloride? Very easy this is. It will form zinc hydroxide and you will get sodium chloride again, okay? It will form zinc hydroxide and you will get sodium chloride, okay? Alright, yes, got it, cool. Then again, if you take zinc hydroxide and make it react with sodium hydroxide, you will get soluble complex. You will get a soluble complex like this. Now let's go to sodium carbonate. Somebody was asking me sodium hydrogen carbonate. No, we are reaching there. Sodium hydrogen carbonate, we are reaching there. Let's do sodium carbonate, okay? Let's do sodium carbonate. In fact, here also you will see that sodium hydrogen carbonate is formed. Sodium hydrogen carbonate will also form. Now see, this reaction looks very complex, no? It is looking very complex, isn't it? But if I just break it down, trust me, you will find it very easy. So for the process of sodium carbonate, which we with love, we call it washing soda. What washing soda? Washing powder Nirma, detergent powder Nirma. That only is your washing soda. What is washing soda? Sodium carbonate decahydrate. Note it down. Sodium carbonate decahydrate. Okay. How do we prepare it? We prepare it with the help of Solvay process. Yes, Solvay process. What do we need? We need excess ammonia. 2NH3, not just normal ammonia we need. How do we remember all this? I'll tell you the tricks, no? Very easy, see. Sodium carbonate, Solvay process. Sodium carbonate, Solvay process. Yes, now for Solvay process, the first thing that you need is 2NH3. That means excess NH3. Okay, we are taking NH3 a little bit more. Now NH3, when you make it react with water and carbon dioxide, you are getting ammonium carbonate. In the first step itself, you are getting carbonate. You wanted to make carbonate, right? You are getting ammonium carbonate, however, not sodium carbonate. You are getting ammonium carbonate. Now you take the ammonium carbonate, again make it react with H2O CO2. Yes, again make it react with H2O CO2. What do you get? You are getting ammonium bicarbonate. What is Solvay process? This is Solvay process. 4 steps. Solvay process has 4 steps. Solvay process is done by 4 steps, and this process is used to get sodium carbonate. How do we get it? We take some excess amount of ammonia, make it react with water and carbon dioxide, you will get ammonium carbonate. Take the ammonium carbonate, again mix water and carbon dioxide, you will get ammonium hydrogen carbonate. Now take ammonium hydrogen carbonate and mix some sodium chloride in it, you will get NH4Cl, that is ammonium chloride, and you will get sodium hydrogen carbonate. Now from sodium hydrogen carbonate, just heat it, it will decompose and give you sodium carbonate. Understood? Understood? Once again everybody, let's do this. Ammonia, water, carbon dioxide. These 3. Ammonia, water, carbon dioxide. What do you get? Ammonium carbonate. Take ammonium carbonate, repeat the same step. Water and carbon dioxide. What did you get? You get ammonium hydrogen carbonate. Take the ammonium hydrogen carbonate. Mix a little bit of salt. Put a little bit of salt in it. Okay. Once you put a little bit of salt, you get, because you have to add sodium here, no? Till now you are only getting ammonium carbonate, but what do you need? Your end product should be sodium. It should have sodium carbonate, but you are getting only ammonium carbonate. So you have to replace the ammonia with sodium. So you take ammonium bicarbonate and add sodium chloride. What will happen? You will get sodium hydrogen carbonate and ammonium chloride. Yes. Now what you do is you take the sodium hydrogen carbonate, just heat it. Just heat it. You will get sodium carbonate. Acha, now one more important thing that is very, very important. Take a look at it. Do you know that this NH4Cl, from this NH4Cl, you can get back this ammonia? You can get back this ammonia. You can recover the ammonia that has been used in this experiment by using this. With this NH4Cl, what you have to do is, only thing is just add calcium hydroxide. You add calcium hydroxide, you get a byproduct, that is calcium chloride, and you get the ammonia. See, the ammonia is back. You can get the ammonia back. That is your Solvay process. Okay, madam, ammoniated cation and electron concept, please. Vidya, I have already taught you. Would you mind just rewinding it back and watching it again? Yeah? Would you mind just watching it again? Yes. It is the major industrial process for the production of sodium carbonate. Now, everybody, do we realize, or have we learned this? Have we learned this? Everybody, once again, Solvay process has 4 steps. First one, ammonia, 2NH3. Water, carbon dioxide, we get ammonium carbonate. Ammonium carbonate, once again, water, carbon dioxide, ammonium hydrogen carbonate. Ammonium hydrogen carbonate, add a little bit of salt in it. What will you get? You will get sodium hydrogen carbonate and ammonium chloride. This ammonium chloride will be kept aside and we will use it to get our ammonia later on. And this sodium hydrogen carbonate, we will just heat it and we will get our sodium carbonate. That's it. Easy process. Solvay process is easy process. Yes? Clear? La. Can I get some la? Just so that I understand that we can move on. Can we move on? Easy? Okay. Alright. Okay, Vidya, we will talk about that. Okay, now please focus here. Focus here now. Chalo. Now let's go for sodium bicarbonate. So sodium bicarbonate, how are we getting sodium bicarbonate? Remember, just some time back also we were getting sodium bicarbonate. Yes, see, here also we are getting sodium bicarbonate. That's it. You get sodium bicarbonate here only, no? That's it. That's how you can prepare sodium bicarbonate. Sodium bicarbonate is basically your baking soda. Yes, it is basically your baking soda. Now, when you put it, what happens? Slight bit of carbon dioxide is produced, and that carbon dioxide makes your cake, bread, pizza dough, everything else fluffy and nice and smooth. Okay. All right. So, whenever what happens? See, effect of heat. You heat it, you keep baking soda in your cake, then you heat it, and what happens? You get carbon dioxide. This carbon dioxide is the main reason for making your cakes, making your bread, making everything else that you bake basically, whatever in that you put. Sodium hydrogen carbonate will be fluffy and smooth because of this. Okay. Reaction with acids. Sodium bicarbonate, do you agree that it is basic in nature? Of course, it is basic in nature. That means that it can react with acid. It can react with acid. Yes. And when it reacts with acid, what is it giving you? Just a normal acid-base reaction, my dear student. What do you get? Salt water, right? You're getting salt water and slight bit of carbon dioxide. Yes. And you have slight bit of carbon dioxide. Ma'am, you have some other job other than teaching? No. I'm a full-time employee at Vedantu. What are you saying? I'm a full-time employee and not now. 2019 say I've been with Vedantu. What are you saying? Why will I have a different job? Anyway, reaction with bases. Yes, it does react with base also, and it will give you sodium carbonate and water. Okay. Now we come to calcium oxide. So group 1 important compounds is over, my dear student. Last leg of the session. Let's quickly complete it. Okay. Calcium oxide. What do we call calcium oxide? Quicklime. Yes, we call calcium oxide quicklime. Okay. How will you prepare it? You can heat limestone. Take some limestone, heat it at 800 degrees Celsius. What will happen? Calcium carbonate will become calcium oxide and carbon dioxide. Oh, by the way, this reaction is reversible. This is a reversible. Okay. This is a reversible reaction. Okay. Moving on now. Action of water. So, if you take calcium oxide, which is quicklime, you slake it. This process is called slaking the quicklime. Okay, slaking the quicklime. So what do? You take calcium oxide, add some water, you will get slake lime. Okay, you will get slake lime. Ma'am, is NCERT enough for organic and inorganic chemistry? To be honest, yes, but you will require a little bit of practice, my dear student. Okay, you will require a practice. I saw you the day before yesterday. Where did you see me? I did not go out anywhere. No, I didn't go anywhere. I don't know. You probably would have seen someone else. I am only working with Vedantu Bacha. I do not know where you got that information. But if you got it from somewhere, it is wrong. You can also come and talk to my office people. There is a background check and everything that is done. I am not working with any other company. Now, calcium oxide is metallic oxide. Metallic oxides are basic in nature. So that means that metallic oxide being basic in nature, do you think that it will react with non-metallic oxide which are acidic in nature? Yes, it does. See, calcium oxide will react with silicon oxide and it will give you calcium silicate. See, calcium oxide will also react with P4O10 and it will give you calcium phosphate. See, you're getting it. Because this is basic in nature, it will react with something that is acidic. Correct? Moving on, it also reacts with carbon, my dear student, and you will get calcium carbide. It also reacts with, calcium carbide can react with nitrogen and it can give you nitrolime. Okay, it can give you nitrolime. Remember this. There may be questions on this also. Nitrolime. Okay, how can you form nitrolime? Cool. Okay, now we go to calcium hydroxide. How do we get slake lime? Calcium oxide, quicklime, slake it with water, you get slake lime. Okay, by the action of water on quicklime, you will get slaked lime. Okay. Oh hi, thank you so much Abhinaya Ravi. Thank you so much. Now, what is the action of carbon dioxide? This you learnt in your lower grades, no? Lime water turns milky on passing carbon dioxide gas. We all know this, right? This is not something that I have to teach you. I know this. So calcium hydroxide react with carbon dioxide. What do you get? You will get milkiness, calcium carbonate, yes, and water. Calcium carbonate, excess of carbon dioxide and water, you will get calcium hydrogen carbonate, which is soluble, and so again heat it. After heating, what will happen? It will decompose and it will become calcium carbonate. Okay. Alright, action of chlorine. Yes. What will you get? You will get CaOCl2 and water. Okay. You will get CaOCl2 and water. Then again, if you take calcium hydroxide and chlorine, yes, and chlorine and heat it, you will get calcium chloride, water and oxygen. Finally, calcium sulfate, that is gypsum. Okay. Gypsum and plaster of Paris, do you remember it from your 10th standard, my dear student? Gypsum is what? Calcium sulfate dihydrate. Gypsum is calcium sulfate dihydrate. Plaster of Paris is calcium sulfate hemihydrate. Plaster of Paris has half H2O. This one has 2 H2O. This is dihydrate, that is hemihydrate. Okay. How do you prepare it? You take calcium sulfate dot 2 H2O. It is naturally occurring. It is naturally occurring. It can be obtained by the action of dilute H2SO4 and soluble calcium salt below 60 degrees Celsius. So, you know, just normal. It's not too heavy experiment anyway. So, calcium chloride and dilute H2SO4 will also give you hydrochloric acid and calcium sulfate. Cool? Alright everybody. Now, what is the action of heat? What is the action of heat? See, told you. Gypsum. Calcium sulfate dihydrate, when you heat it, you will get plaster of Paris, which is calcium sulfate hemihydrate. What do we mean by hemihydrate? What do we mean by half H2O? Half H2O means one H2O is being shared by 2 calcium sulfate. Okay, one H2O is shared by 2 calcium sulfate. So that is why. So either you write 2 CaSO4 dot H2O or you can write CaSO4 dot half H2O. Alright, you can have CaSO4 dot half H2O. Alright, then you get anhydride. You get calcium sulfate anhydride and some amount of water. It forms an important fertilizer, NH4 2SO4. This also we have learnt in our lower grades. Yes, this also we have learnt in our lower grades. Optimal learning, either you are buttering me up or you don't like me teaching. I don't understand which one is it. Either you don't like my teaching and that's why you are asking me to, like, you know, ma'am, you continue your research and everything, or you are probably very fond of me and that's why you want betterment of me. I do not know which one is it. I can't figure it out. Anyway, so calcium sulfate, when it reacts with ammonia, carbon dioxide and water, you will get calcium carbonate. This symbol means precipitate. Okay, you are getting precipitate and you are getting NH4 which is a important fertilizer. And then finally again plaster of Paris, as I told you, plaster of Paris is obtained just by heating gypsum. You heat gypsum, you will get plaster of Paris, because the water of crystallization flies away, 3/2 water of crystallization flies away and you are left with hemihydrate. Okay, you are left with hemihydrate. Properties, we can just read through it. It's not that important also, but just read through it. It is a white powder, property of setting to a hard mass. You know, you plaster your hands or you can make, you know, a lot of idols and statues and all of that. Yes, and when it is heated to 200 degrees Celsius, that half H2O also flies away and you only get anhydrous calcium sulfate. Anomalous behaviors of lithium, this I have actually taught you yesterday a little bit, if you remember. See, I have taught you, know, lithium, because of its small size, exerts greatest polarizing effect out of all the alkali metal ions, and it forms covalent character. Have I taught you this? Have I taught you this? Hydraulic motor. I'll teach you that also, but not right now. Currently, we do not have this here. Okay, I'll teach you this later. Okay, Vidyashri? Yes, Chinmay, thank you so much. Chalo, moving on. This you know already, I have taught you this. Now, we also know that lithium has the highest ionization energy and electronegativity as compared to other alkali metals. Why? Because of small size. Again, small size. So, obviously, highest ionization energy, no, small size, the nucleus will be able to pull the electrons. It is not affected by air easily. Once again, because it is on the top, it will act a little crazy, if you remember. Yes, and it is more harder and lighter than other alkali metals. You know what, this I'll give it to you in the notes. If you just read through it, you will understand. I have explained this on and off throughout the 2 sessions. So just go through this, and also remember just one little thing, that is your diagonal relationship. Lithium has a diagonal relationship with Mg. You will get a lot of similarities between lithium and magnesium, and same goes with beryllium as well. Beryllium also has a diagonal relationship. Okay, beryllium also has a diagonal relationship. You can see beryllium here. Okay, just read through. See, beryllium has a diagonal relationship with aluminium. So that's all for today, everybody. I'll send you the notes in the Telegram channel. Do join the Telegram channel, everybody. Please do join the Telegram channel. And biological importance, you know that sodium is present in our blood outside your cell. Okay, it regulates the nerve signals, whereas potassium is required for production of ATP, that is adenosine triphosphate. Adenosine triphosphate is what gives you energy in your body. Yes, you must have learnt it in biology. Chlorophyll has magnesium, and all enzymes that utilize ATP in phosphate transfer require magnesium as a cofactor. Link is present, or you can just search for Vedantu Enlite in Telegram, you will find it. Okay, we know about this also. Calcium is present in bones and teeth, right? Calcium plays important role in neuromuscular functions, interneuronal transmission, and blood coagulation. And that's it. This is my Instagram account if you want to be in touch with me. And thank you so much. With this note, S block chapter is over. However, we will do one session on important questions from S block. Okay. So with this note, tara bye everybody. See you all very soon. I'm gonna send you the notes. Go through the notes once again. Okay. And from the next class, we will start with EM set. Okay. We will start with EM set. Lots of love. Bye bye everybody. See ya guys. See ya soon.